day is the proportional unit, lesson 9, the second day of rate of change. The homework that goes along with this is page 24 to 26. We are on page 30 in your note packet. All right, example 1. Veronica is mulching her front yard. The total weight of mulch varies directly with the number of bags of mulch. What is the rate of change? Well, first thing we need to do, let's take a look at this graph. Is that graph proportional? Think about it for a second. It is proportional because proportional graphs satisfy 2 requirements. 1, it is a straight line. 2, it goes through the origin. So the graph is proportional. It is also what we say, it varies directly. They're the same thing, proportional and direct variation. Now, how do we find the rate of change? Remember, K is Y over X. It is the rate of change. It is the constant of proportionality. It is also called the unit rate. They are one and the same. Every one of them is the same. And on a graph, where is K located? It is located at X is 1. Now, this one is easy to read because if I go right here, it's a major intersection. That is the point 130. So, our constant rate of change is 30 pounds per bag. Rate of change, 30 pounds per bag. All right, here's another one. The height of the water as a pool is being filled as shown in the graph. Determine the rate in inches per minute. Again, look at this. It is a straight line through the origin. Where's our rate of change or constant of proportionality or unit rate located? At X is 1. However, if I look at this graph where X is 1, can I look up here and see what Y is? No, you cannot eyeball it. It is not a major intersection. So I go to another point that is a major intersection. Any one of these points will work. And we need to remember that K, which is, again, the rate of change, the constant of proportionality, or the unit rate, they're all the same, is Y over X. So remember, this is XY, this is XY, this is XY, this is XY. You can take any one of those points and do Y over X. So, to this. So, our rate of change is 2/5 of an inch per minute. Inch per minute. 2 inches per 5 minutes. Now, you can divide that and get 0.4 of an inch per minute or leave it like it is. All right, find the rate of change. Our rate of change. Y is, I'm sorry, why am I saying Y? K is Y over X. So our rate of change, 12 over 1, or we could do 24 over 2, or we could do 36 over 3, or we could do 48 over 4. All of them are going to be 12. What is it? $12 per whatever this time is. Maybe it's $10 an hour, $10 a minute. It doesn't tell you. I'm sorry, $12 an hour. But it's $12 per whatever. All right, here we go again. The money Shelley earns varies directly with the number of dogs she walks. Again, is this graph proportional? Absolutely. Straight line through the origin. Where is our unit rate or rate of change located? At X is 1. It is a major intersection. It's the point 1, 2. So our rate of change. How much does Shelley get for each dog she walks? $2 per dog. $2 per dog. Y over X. But this one is located right at 1. The number of cakes baked varies directly with the number of hours the caterers work. What is the ratio of the cakes baked to the hours worked? Well, let's look at X is 1 again. We go up here, 130. So, what is our ratio? K is 30 over 1, or 30 cakes per hour. Remember, in a graph, it is always located at X is 1 if it is a proportional graph. All right. The The table on the right shows the number of markers per box. What is the constant rate of change? Well, here we go. Our rate of change, K, is Y over X. So we'll have 8 over 1, 16 over 2, 24 over 3, and 32 over 4. What is our rate of change? It is 8, why am I doing a dollar sign? 8 markers per box. Okay, and this is a graph.